The universe is full of surprises, and astronomers using the Chandra X-ray Observatory have recently made a jaw-dropping observation. In the Pisces constellation, scientists discovered a white dwarf named G2938 that's been devouring the planets that orbit it. The dead star's powerful gravity is tearing apart the once massive planets, while turning them into hot glowing chunks of plasma. But not all planets go down without a fight when it comes to being eaten by its host star. Sometimes the star will bite off more than it can chew. Astronomers from the University of California have found that while stars can eat up small planets like Earth with no problem, if a super Jupiter planet plunged into a star, it would create a huge shockwave that could cause the star to expel its entire atmosphere of extremely hot plasma out into space. The process is so intense, it can even tear the star apart from the inside out. The impact is so violent when a planet collides with a star, it breaks apart and sends matter and gas flying out into space. The ejected matter and gas can then come together and form an entirely new world. But these outcast planets often have to endure harsh conditions as they journey through space on their own. How do such wandering planets bend the laws of physics to adapt to their new home in deep, cold space? And what other weird worlds out there does the universe hold? Rogue planets that were once ejected from their original orbits and now wander aimlessly through space are a big mystery for scientists. According to estimations, there are billions of them in the Milky Way alone. Astrophysicists have found that planets from young star systems, where protoplanets compete for building material, are more likely to become rogue planets. In these systems, planets collide with each other or come too close in orbit, causing a larger planet to push a smaller one out into space. But even older planets aren't immune to being cast adrift. A passing star or black hole can disrupt the delicate balance of an established planetary system, ejecting one or more planets from their orbits. An exiled planet awaits a terrible fate. Once outside its star system, its surface cools down to the temperature of outer space. If the planet has oceans of liquid water, it turns into ice. Such a planet would have no seasons or day and night cycle. But Professor Manasvi Lingam of the Florida Institute of Technology believes life may still be flourishing on rogue planets. How is that possible? Imagine a rocky, wandering planet similar to Earth. It can emit heat from its core for billions of years. This heat could be strong enough to melt any ice on its surface and form bodies of water. On Earth, we've already observed this phenomenon. Scientists have discovered liquid water lakes and rivers beneath the ice of Antarctica, home to live microbes, mollusks, and strange fish. Similar life forms may exist under the ice of wandering planets. And if such a planet had a dense hydrogen atmosphere, life could even exist on its surface. Given a rogue world manages to retain its atmosphere, it will keep the heat coming from the core from escaping into open space. A large moon typically orbiting such planets would also add heat, stretching and compressing its neighbor with gravity. The idea of such planets existing is only a hypothesis, but using extrasolar object interceptors, NASA will soon be able to verify if they exist. Extrasolar object interceptors are compact radioisotope electric propulsion probes. If a rogue planet or other celestial body ends up in our solar system, interceptors will travel to it, take samples, and go back to Earth. Spacecraft with this technology can even catch up with an extrasolar object and return back to our planet with samples within 10 years. But outcast planets aren't the only planets that intrigue scientists. Located in the constellation Virgo, 2,300 light-years away from us, is PSR B1257+12, also known as Poltergeist. This planet has long been a source of mystery and intrigue for astronomers. Its existence is particularly baffling because it orbits a pulsar, which forms when a massive star collapses in a violent explosion, leaving little chance for any planets orbiting it to survive. Yet, against all odds, Poltergeist not only survived, but remained intact and unharmed. Astronomers found out that the planet is made up of space debris. After a supernova explosion, a multitude of pieces from shattered celestial bodies were thrown into space, and over time, they formed Poltergeist. According to scientists, the planet should have a solid rocky surface. The magnetic field of its star is one of the most powerful sources of microwave radiation, and poltergeist is constantly subjected to ionizing radiation. Such conditions are deadly for all living things, but not on this planet. Recent studies suggest that a dense and extensive atmosphere could make poltergeist habitable, as it would shield the planet from harmful X-rays and gamma rays. However, the radiation levels on the planet are still much higher than those on Earth, which would limit its habitability to only simple organisms rather than more complex life forms. For example, on Earth, a resilient bacterium called Deinococcus radiodurans has shown the ability to survive in radiation levels 500 times higher than those that humans can withstand. So it's possible that similar organisms could also survive on poltergeist. The huge exoplanet Beta Pictoris b, located 63 light-years from Earth, is another unique world. It had long been hiding from scientists in the dense layers of gas and dust around its young star. The Beta Pictoris star is just about 20 million years old. In 2022, astronomers discovered 30 exocomets in the star's system, very similar in size to comets in our solar system. After years of peering through a veil of thick dust, scientists have finally seen the true face of Beta Pictoris b. For 4 years, scientists tracked the planet's movements around its star using the Very Large Telescope, and recently, these stunning images were released. Beta Pictoris b, a supergiant planet, has a radius of 1.65 times and a mass of about 11 times that of Jupiter. It rotates rapidly, completing one revolution on its axis in just 8.1 hours, faster than the solar system's gas giant, which takes 10 hours. But the main mystery of the planet remains unsolved. Beta Pictoris b is located at a distance of 10 astronomical units from its star, about the same distance as Saturn from the Sun. However, according to astronomers' calculations, the gas giant has a temperature of 1,451 degrees Celsius, which shouldn't be possible at that distance from its star. One possibility is that the heat is being retained due to the planet's huge mass and dense dust cover, a hypothesis that is yet to be confirmed. In the realm of massive gas giants, there's one more celestial body that reigns supreme over Jupiter. AB Aurigae b, detected by astronomers in 2022 in the Aurigae constellation, is 9 times more massive than our solar system's gas giant and has a radius of 1.12 times that of Jupiter. Scientists called AB Aurigae b the elephant planet, and it's still forming in the system of its young star, which shines 38 times brighter than the Sun. On top of that, the planet keeps growing, defying all physical laws. It huddles on the outskirts of its star system, more than twice as far as Pluto is from the Sun, and almost 100 times farther than Earth is from our star. A year on the exoplanet lasts 587.7 Earth years. According to standard scientific models, at this distance from the star, AB Aurigae b couldn't have acquired such a huge mass. Typically this happens because matter and gas are drawn by gravity towards the protoplanet's core, but there doesn't seem to be much building material for the planet on the outskirts of the star system. This means AB Aurigae b must have formed in a different way. It's possible that planets can be born from space debris. When the disk around a young star cools under the influence of gravity, it sometimes breaks up into planet-sized pieces. One of these pieces might have added to the formation of the giant planet. It continues to grow by absorbing the gas surrounding it, which is still abundant in the young star system. In terms of mass, AB Aurigae b is already approaching a threshold separating it from a brown dwarf. But let's take a look at another system where there's a noticeable disproportion in sizes. The planet GJ3512b is only 30 light-years away from Earth. This is a gas giant from the constellation of Ursa Major, and it's half the size of Jupiter. It revolves around a red dwarf that's almost 5 times smaller than the Sun and 50 times fainter. The mass of the red dwarf GJ3512 is no more than 270 times the mass of the planet, while the Sun is about 1,050 times more massive than Jupiter. The discovery of a gas giant like GJ3512b revolving around a small star challenges conventional beliefs about planetary formation. It was previously thought that only Earth-sized planets or more massive super-Earths could exist in such systems, and that gas giants could not form around small stars due to the lack of gas and dust in their disks. However, this assumption may have been due to the difficulty of detecting such planets in the dim light of their parent stars. These giants are believed to form from debris in stellar disks, but the scarcity of material in the disk of a small star makes the presence of a gas giant like GJ3512b even more surprising. Scientists hope to unravel the mysteries of these worlds, primarily with the help of the James Webb Space Telescope and the European space mission Ariel. It will launch in 2029 with a focus on studying exoplanets. We hope you enjoyed this journey through some of the most fascinating planets in our universe. If you liked the video, then let us know by clicking the super thanks button, and make sure to stay tuned here to stay up to date with the latest discoveries in space exploration and technology. Thanks for watching.